Okay, in this video, I'm going to introduce you the derivatives. And this is a very important thing in calculus, and most probably this is going to be the introduction to the calculus. Um, okay, so the derivative. Derivative, to understand what is a derivative, first we have to go into the principles and understand what's the use of finding a derivative of a function, right? So here, um, in order to understand the principle of derivative, first we're gonna go to the basic principle called as average rate of change. If you can understand this principle, the average rate of change, um, down the road, it might be very helpful for you to understand what is a derivative function. Okay, so here in this graph, we have a function fx, and we selected 2 points, one A and the second one is B, right? So average rate of change of this line, the line that connects the point A and B, is, as we learn in our other classes, is going to be change in y, delta y over delta x. So this is basically delta y. They wrote this in a fancy way. FB means the y coordinate at the B. So it's, if you put this, so this is going to be FB right here, right? And FA is the y coordinate of A right here, right? So they just got the delta y here divided by delta x. So B is the x coordinate of point B, and A is the x coordinate of point A, right? So basically they rewrote something we knew before in a fancy way using the function notation. They did this purposely because this is going to help us to understand the principle of derivative. So in this video, what I'm going to show you what is a derivative, and then I'm going to show you how to find a derivative at a point of a function. That's what we call as a derivative. So how to find that value, and then I'm going to introduce to you the first principle of derivative, and then I'm going to show you some examples of solving problems using the first principle, the main principle of derivative. Okay, so moving into the moving further in the derivative discussion. So if we consider this function, so the function with all real numbers, fx is equal to x squared, which is going to be drawn as this curve, this red curve. So that is the function x squared. The gradient of the secant pq shown on the graph is, so the gradient or rate of change of pq is the gradient. Is another words, rate of change of the average rate of change of the PQ. This is same as the how we found in the previous slide. So here it's going to be gradient of PQ is equal to change in y. So this is going to be change in y divided by change in x. So let's see. So at Q, so y coordinate, let me get a different color. So let's say blue. So the Q coordinate, the y coordinate of the Q is gonna be a plus h squared. So this is a plus h squared, right? And what is the y coordinate of P? It's gonna be a squared. Right, so this is squared, the This is gonna be whole thing squared. To the whole thing squared, a plus h squared, a squared, right? And let's say what is the x coordinate of q is going to be a plus h. X coordinate of p is a. So from this definition we can find the x distance from a to p to q, point p to q, is going to be h, right? So that's what they did. So they got that difference. So basically delta x going to be h, which is true, right? Delta x in bottom part is going to end up becoming h, right? So when we did this, we got a plus h squared minus a squared. So that's the y difference of delta y. And then we do all the algebra. So the a squared plus double the product of two terms, 2ah plus square of the last term, h squared minus a squared divided by h, and a squared over h, and 2ah over h is going to be 2a, h squared over h is going to be just h, minus a squared over h, and then we can simplify it as h goes to 0, the limit of 2a plus h, as h approaches to 0 is 2a, right? So we can do that. Here this cancels out, a squared and positive a squared, negative a squared cancels out, and so this is going to be 2a plus h. So it's going to be this h, and one h of this also cancels out, so these two cancels out for this. It's 2h. Okay, so the gradient of the line PQ is 2a plus h. So the limit of that when h is equal to 0, that in other words it says when this difference reduces. That means we try to get the derivative of the gradient at this point, at P. So that's what it says. The limit of 2a plus h as h approaches to 0 is 2a. Because when h becomes 0, so h is going to fall out, and then we're going to end up with 2a only. So the gradient of the tangent at P is said to be 2a. So in other words, we found the derivative of this function at point P. So this also can be interpreted as the instantaneous rate of change of the function at this point, at point P, in other words, a comma fa. The straight line that passes through the point P and has gradient 2a is called the tangent to the curve at P. It can be seen that there is nothing special about a here. The same calculation works for any real number x. The gradient of the tangent to the graph y is equal to x squared at any point x is 2x. That means if you draw a tangent to any point of this graph, of this particular function, it's just going to be 2x. Doesn't matter p, it can be q, it can be somewhere else, it can be this point here. So it's going to be 2x. So we say that the derivative of x squared with respect to x is 2x. That's how we say in calculus class. Or more briefly, we can say that derivative of x squared is 2x. So we found the derivative of this function is 2x as h 2x or 2a as h approaches to 0 using the principle of gradient. That's how we do find the derivative using the first principle of derivatives. Okay, so limit notation. So notation for the limit of 2x plus h as x approaches to 0 is, you're going to write it like this, right? So limit, we just put lim, which stands for limit as h goes to 0 right here, and then we put in within brackets the function that we want to find the limit. The derivative of a function with rule fx may be found as finding an expression for the gradient of the line through p, x, point P and Q, right? Finding the limit of this expression as h approaches 0, right? That's the limit notation. Okay, so when you go further in your calculus class, we are not going to do limit notation anymore. We're going to go into the basic principles of derivatives and just going to find the derivative. But as the introduction to the derivatives, for the first chapter, for the first section of the derivative chapter, we're going to use this limit notation and try to find the limit of a function to find the derivative at a point. Okay, so the definition of a derivative. So we have another function here. It's a different function. So y is equal to fx. And the derivative of the function f is denoted f dash. So this is very important. Every time, so f is the function, the derivative of a function is always denoted as like this. So that's this little dash on top of f represents the derivative. So if you see, if they give you something like this, fx is equal to 5x squared plus 10x, and if they say find f dash, that's a question, that means find the derivative of fx respect to x. Or in the basic principle, and in this lesson we're going to find what is the limit when h approaches 0. So in this section we're going to say f dash x is the limit h goes to 0, and we have to use this equation every time when you find a limit. Fx plus h minus fx divided by h. X plus h means that's going to be the difference between x coordinates, so change in y divided by change in x, and we solved this in the previous equation and we came up with this equation. So we have to put into this form, and then we are going to simplify it and then put the limit when h goes to 0, and basically we just gonna plug in 0 instead of h at the last step. And yeah, so let's go to this example. Okay, differentiation by first principle. Find limit as h goes to 0 fx plus h minus fx divided by h. So this equation right here is very important. So every time if you want to find a limit in a derivative, you have to use this equation for each of the following. So fx, so they gave us the function, so we had to find, so the function is 3x squared plus 4x plus 6, right? So I'm going to show you, I'm going to go by step to show you the answer. So first thing we had to do is write this equation plus h. So fx plus h, so every time you see a x, we have to put a plus h on it. So it's going to be 3 within bracket x plus h squared plus 4 x plus h just for the x. So we have to treat x as an individual variable. So now it's not just x, it is x plus h. So x plus h, every time you see a x, it's going to be x plus h plus 6 minus fx. So you're just going to rewrite this function again here, right, divided by h. And then we're going to simplify this. We have to simplify this expression, right? So it's going to be x squared plus double the product of two terms, 2xh plus square the last term, x squared, and then distributive property, so 4x plus 4h plus 6, and we write the last part of this divided by h. And then next part is using the applied distributive property for the first part of the equation, so it's going to be 3x squared plus 3 times 2 is 6xh plus 3 times h squared, 3x squared plus 4x plus 4h plus 6 minus 3 squared plus 4x plus 6 divided by h. And then it's a matter of simplification, so as h is in the denominator, so we have a h in every term. So what I did was I just wrote down h every term, and if h cancels out, I just write the h on there. So in here, so it's going to be 6xh over h, so h cancels out, so it's going to be 6x. And then finally, as h goes to 0 in this term, h goes to 0, so 3x squared divided by 0, undefined, so this whole thing is going to be 0. So here there's no h, so this is going to stand out. Here 3 times h, instead of h we're going to plug in 0, so it's going to be 0 again. And here also 0, here 0, and everything divided by h is going to be undefined, so it's 0. So we ended up having 6x plus 4. So that's the derivative of this function respect to x. 6x plus 4. Whatever this function is, when you draw this, whatever that function comes up to be, in every point, at a given point, at given x, when you can plug in any value for this x at x at 10, at the if x is 10, so it's going to be 6 times 10 is 60 plus 4, 64. The derivative at that point is going to be 64, instantaneous rate of change. At that instant, y value is this. Okay. We have some practice questions, and I'm going to do it as a separate video. And if you like my video, please subscribe to my channel and support my channel. Thank you.